Good afternoon. I'm Gori, and I'm going to present part of the results from my MRS dissertation that was supervised by Dr. Chris and aimed at investigating the error and uncertainties in U-value estimation from in-situ measurement collected in samples. So as you may know, U-values are a thermodynamic, thermophysical quantity that represents how easily the heat flows through a building element. U-values are also one of the key parameters during energy needs simulation, and therefore an accurate knowledge of U-values would be really interesting in order to have hopefully more reliable results of energy needs simulation. At present, there are two ways of computing U-values. The first one is by knowing, having an accurate knowledge about the building structure and inferring the thermal conductivity and other thermodynamic variables from the literature. Well, the second one is to perform in-situ monitoring campaign and from that infer the U-values. In this second case is more interesting and useful because it doesn't need previous knowledge about the wall, and also allows to characterize the building in its environment and state of conservation, and therefore to customize intervention and heating or cooling plant sites. So my case study was located at the UCL-Energy Institute. I surveyed a solid brick wall, so we removed the plasterboard in order to access directly the solid brick, and we instrumented the wall with some sensors, a number of sensors. I surveyed the wall for 6 weeks, from end of May to beginning of July 2013. And these are some of the results I obtained from the 2 sensors in the small picture there. As you can see, I subdivided the whole data series I collected into 6 smaller data series, one week long each. And I computed the U-values by using a novel building simulation technique that has been developed at UCL by Dr. Bidu. And the U-values I obtained are quite comparable with the literature and quite close to each other. So this one for the first sensor and the one for the second sensor. But as you can see from the graph, there are some systematic error affecting the U-value I obtained. And this could be due, for example, to calibration factors, but also to inhomogeneities in the wall. And therefore, from this graph, what we can see is that maybe using just one spot measurement to characterize the whole performance of a building element can be affected by uncertainties and be a little bit representative of the building element. And so during my PhD, I'm going to continue to explore this, the building physics of elements and prediction of U-values. And so I'm going to continue monitoring, further case study, further implementing this novel technique, and also investigating the error and uncertainties associated with this. However, I'm still in the process of refining my research question, so would really appreciate to hear your comments or inputs on this. Thank you.